Today we will be talking about volumes of spheres and composite solids. And what a composite solid is, it's just two or more solids combined. So if you think about your house, your house, you have all your rooms, like your main floor, which is usually rectangular, and then the roof above that, it's a pyramid shape. So you could think of your house as a composite solid, where at least in my case, it's a rectangular prism and then a rectangular pyramid on top for the roof. And a sphere is just a ball, so like a tennis ball or beach ball. Those are examples of spheres. The definition of a sphere is the set of all points in space equidistant from a given point. So if we look at this picture right here, this is our center, our point, and all of these, I'm going to zoom in a little bit. Every dot on this sphere is the same distance away from this center. So just think of it as a ball. And to calculate the volume of the sphere, this is the formula that we use. 4/3 or 4/3 times pi r cubed. Now it's different than area where we've squared the radius. This time we are taking it to the third power or cubing it. And r is the radius. So let's look at some examples. First one, find the exact. Remember, when it says the word exact, that means pi is in the answer. Or you can think of it as just the pi symbol. All right, the volume is going to be 4/3 times pi times the radius to the third power. The radius is 12, so 12 to the third power. So then in the calculator, it's probably easier to type in 12 to the third power first. So let me show you. 12 to the third power. Take care of the radius part, then multiply it by 4/3. And we get 2,304. It's just, I think if you try to deal with the 4/3 first and then try to cube the 12, it might get a little bit messy and you might hit a button by mistake or do something in the wrong order. So I always deal with the radius cubed first. So our answer was 2,304 pi. Because pi is still there, we just dealt with all the numbers. Cubic feet. Volume is in cubic units. And then number 2 says a beach ball has a diameter of 15 inches. Find the volume to the nearest hundredth. So if the diameter is 15, that means the radius is 15/2 or 7.5. So then we can just go say the volume is equal to 4/3 times pi times 7.5 to the third power. Now, since this wants us to get a decimal approximation, I would type this into the calculator just as you see it. So 4/3 times pi times 7.5 to the third power. And we get 1,767.14. And then I think we need to round that. Yep, 1,4, and the 5 back here means we're going to round that to cubic inches. And then example 3 is find the radius of a sphere with the volume of 36 pi cubic centimeters. So we're just going to go backwards. 36 pi is equal to 4 thirds times pi r cubed. So because we have pi on both sides, we can divide both sides by pi just to get rid of it. That we don't have to worry about this anymore. So then we are left with 36 equals 4 over 3 times r to the third power. At this point, you could do a couple things. You could multiply by the reciprocal of 4 thirds, and that would just get everything done in one step. Or you could multiply both sides by 3 and then divide by 4 afterwards. It doesn't matter which way you do this in. For this time, I'll do it the slightly longer ways. Whoops. So I'm going to multiply both sides by 3. That way these 3's cancel. So then I am left with 3 times 36, which is 108, equals 4r to the third. Divide both sides by 4. We get 27 equals r to the third. Now to find the cube root in these calculators, like I've always said, every calculator is a little bit different. For this calculator, if you press the math button and you see the fourth one down, that is the cube root. And that gets you 3. Another way you could do this is put 27 in parentheses and raise it to the 1/3 power, and that will also give you 3. So 3 is equal to r. Our units are centimeters. So 3 centimeters is equal to r. There we go. Okay, so let's deal with some composite solids now. Remember, composite solids, that's just 2 or more solids put together. It's not really that difficult to do. It's more of finding the time to do the calculations. It's more of an exercise in using all the volume formulas together and doing those calculations and then adding them up. So if we look at this example here, this is just like the house I was talking about. We have a rectangular prism, which happens to be a square base. All sides here are 6, so it's technically a cube. And then we have a pyramid on the top. So we need to find the volume of each of these shapes separately and then add them together. The volume for the cube, so the volume of the cube, because it's a rectangular prism, we can just multiply the base, or the length, the width, and the height. So 6 times 6 times 6, which gives us 216 cubic meters. Now for the pyramid, that's going to be the area of the base, which is the same area as the cube. They have the same base, and then the height is also 6. So it's still going to be 6 times 6 times 6, but remember, because it's a pyramid, we have to divide that by 3. And when we type that into the calculator, we get 72 cubic meters. So just think of these two problems separately, and then we're going to add them at the end. So we found the area of the cube, and we're going to find we found the area of the pyramid, and then we're going to find the volume of the whole thing. And that's 288 cubic meters. So in this one, because the bases were rectangular, you remember squares are rectangle, we could just multiply 6 times 6, and this gave us the area of the base. If you had a different shape base, then you'd have to find the area of that separately and then multiply it by the height. All right, let's look on the next page. We have another cube. And then we have this weird shape on top. Well, this shape up here is half of a cylinder. So think about your pot can cut in half vertically. And that's what we have on top of here. Well, it's like, well, we never dealt with half of a shape before, or half of a solid. Well, we're just going to pretend that it's a whole solid and then divide that by 2 at the very end. So what I want you guys to do is I want you to find the volume of the cube. You'll calculate that. And then I want you to calculate the volume of the cylinder. Pretend the cylinder is full, a full cylinder right now, and then we can divide it by 2 later. The radius of this cylinder, you're going to have to figure out, well, if this side is 4 right here, that means this is 4 as well. Oh, that tells us the diameter of the cylinder is the same length as the side of the cube. So the diameter is 4, which means the radius is 2. Okay, so now that I've given you the radius, go ahead, pause the video, and figure out the volume of each of these shapes. Okay, these are the answers I got. Now the height of the cylinder may have been a little bit difficult to figure out that it was 4. Remember, the height is how tall the cylinder is, and this cylinder is kind of on its side here and on top of the cube. So the height of this cylinder is 4. Well, this is only half of a cylinder, so what we need to do is take this 50.26 and divide by 2, and that gives us 25.13 cubic inches. So now that we have the 2 shapes, the cube and the half cylinder, we can go ahead and say, okay, the volume is going to be 64 plus 25.13, which gives us 89.13 cubic inches. All right, let's look at number 5 down here. So we have this pill capsule, and if you think about a medication pill, you'll see or recognize that it's not a perfect cylinder. It's a cylinder with like 2 half spheres on either side of it. So that's what we have. We have 2 half spheres, and in between those 2 halves, we have a cylinder. And we want to find the volume of this pill capsule. Well, we have this cylinder, and we have 2 halves. So we have 1 half spheres. Well, if we have 2 halves, together they become 1 whole. So you may think that we're going to have to divide by 2 to find the volume of the half of a sphere, but because we have 2 halves, we can just combine them together as 1. So let's find the volume of the sphere, and that's going to be 4/3 times pi times the radius cubed. Well, they're telling us the radius is 2 right here. So 2 cubed. The directions say round to the nearest hundredth, so we're just going to type that into the calculator. And that's going to give us 33.51 cubic centimeters. Then we will worry about the cylinder here. And then we're going to do the formula pi r squared times h. The radius again is 2 times h. The height they're telling us is 7. So we type this into the calculator, and that gives us 87.96 cubic centimeters. And then we can add those up. So the volume is going to be 33.51 plus 87.96, which gives us 121.47 cubic centimeters. So like I said before, the problems aren't complicated in the sense of that you're using stuff that you don't know or that you haven't seen before. It's just putting all the formulas together. So you have to recognize what shape it is and what formula to use. And do they give us the radius? Do they give us the height? And stuff like that that you're going to have to figure out. Once you got those things down, you just plug them into the formula and then add everything up to get your total volume. All right, let's look at the next problem here. A solid consists of a hemisphere with a radius 1 meter on top of a cone with the same radius and a height of 5 meters. Find the volume of the solid to the nearest hundredth. So what we'll do is we'll draw the picture, and then I'll have you guys try to calculate the volume on your own. So a hemisphere is a half sphere, and it's on top of a cone. So we have a cone, and then we have a sphere on top of it, or a half sphere. And this is where they meet. So think of it as an ice cream cone. Now the radius of both shapes is 1. So the radius of the hemisphere is 1, and the radius of the cone is 1. We are also told that the height of the cone is 5. So you have all the information needed to calculate the volumes of each of these shapes. So remember, the hemisphere is half a sphere, so treat that as a whole one at first, and then divide by 2. So go ahead, pause the video, and try this problem. And once you've tried it and got an answer, unpause it to see if we got the same thing. Okay, so look at what I got. Final answer is 7.33. And you can see my work for the sphere and the cone. I remember when I found the volume of the sphere, I then later divided by 2 to get the volume of the half sphere. All right, let's look at example number 7. We have a pool with the dimensions shown, and it has been emptied for cleaning. How many gallons of water does it take to completely fill the pool? Because you think about it, a pool has a shallow end and a deep end. So you can think about this up top as the pool, the water, the top of the water, and then down here, the pool gets deeper as we go into the pool. So to calculate the volume of this, or how many gallons of water that can fit into it, we're going to have to break this up into 2 shapes. What we should do is take this right here and draw a line. Because what this does is it creates 2 shapes. We have a rectangular prism on top that I outlined in dark blue. And then we're going to have a triangular prism that I'm outlining in gold. And when I do that, I create a right angle here. So we have the blue rectangular prism and the golden triangular prism. And we need to figure out the dimensions of that triangular prism. Well, if this whole distance here is 10, and the blue part is 4, that means the golden part, or what's left over, has to be 6. So this distance right here is 6 feet. Now we need to figure out this side, the length of this right here. Once we do that, we have the base and height of the triangular face, and then we can calculate the volume. Well, I just outlined one of the blue lines, which is the same as this length up here. So this is going to be 164 feet. So now we have our two shapes, and we can calculate the volume of these. So the volume of the triangular prism, let's do that one first. So the T prism, we got to find the area of the triangle base first. This is a triangle base right here. That's going to be, so the base is going to be 1/2 times 6 times 164. So that will give us the base of that prism. So let's type that in the calculator real quick. So 6 times 164 divided by 2. And we get 492. Okay, so then we need to do 492 and times that by the height. Well, what's the height of this going to be? Remember, the height of any solid connects the two bases. So the height is going to be this distance right here. So then we have to figure out, okay, based on the information given, how long is this light blue line? Well, it's the same as this line, which is the same as this line, or 82 feet. So we multiply this by 82, and that gives us 40,344 cubic feet. Now we have to worry about the rectangular prism. The rectangular prism will be easy because since it's a rectangle, we can just do 4 times 82 times 164. Just multiply all the dimensions and we get 53,792 cubic feet. So altogether, the total volume, we're going to add up these numbers, and it gives us 94,136 cubic feet. That's not what the question's asking, though. The question says, how many gallons of water? Up here, 1 cubic feet, or 1 cubic foot, is 7.4805 gallons. So we need to take this number here and multiply it by 7.4805 because that's how many gallons are in 1 foot. We want to figure out how many gallons are in 94,136 feet. So 94,136 times 7.4805, and that gives us 704,184.348 gallons. So that is how much water there is in this pool. I know this part of the problem, there was a lot going on. We had to break up our pool into shapes that we knew, and then we had to do some thinking and reasoning to figure out, the dimensions of each side of that rectangular prism that we were dealing with. But once we got that information, once we were able to get um, the base height uh, of the prism, we were in good shape. We could just use our formulas and we were good to go. Okay, now the last part of the problem, um, the water that is filling the pool flows at a rate of 23 gallons per minute. How long does it take to fill the pool? We're going to cross off this part here. If the water stops 1 foot from the top, because this is going to add a lot more to our calculations. To figure this out, we're going to take the number of gallons. Okay, so we have that many gallons, and we need to divide it by how many gallons we can fill in 1 minute. So divided by 23 gallons per minute. And when we divide that, we get 30,660 16.71 minutes. So that is how long it would take to fill up this pool. It doesn't ask us to convert that into days or hours or anything like that. So we can leave the answer like that. But just for fun, if we wanted to convert that to hours, we would divide this by 60. And that would be 528 hours. And if we wanted to go further and figure out how many days, we would divide this by 24, because there are 24 hours in a day, and that would give us 21.26 days. So sometimes converting our time makes it a little bit more conceptual in what's going on. Like if I said 36 or 30,000 minutes, that may be hard to realize. Okay, how long is 30,000 minutes? Oh, it's 510 hours. Again, that's getting a little bit better, but how long is 510 hours? Oh, it's 21 days. Okay, now that makes a little bit more sense to us. We know, okay, 21 days, that's 3 weeks. That's a lot of time. So just think about that when you're getting your answers. What unit makes sense in what we're talking about. So I hope that this video was easy to follow. I hope that you have a better idea of calculating the volume of composite shapes, combining more than one shape. So make sure you hit the like button and subscribe.